Today we're going to talk about compound Boolean expressions. And then we have a Google practice form, and then we have a REPL to do. So sometimes you need to evaluate more than one thing in an if statement, and for that we have and or operators. So we do an and using two ampersands, that's right here. And we do an or using two vertical bars. It's the key right above the enter key where the backslash is, shift backslash. So right here, if I wanted to say, hey, if guess greater than lower and guess less than upper, I would say your entry is within range. I'm assuming there was a lower and an upper, and we were trying to make sure it was between them. And then here's an or example at the bottom. If guess less than lower or guess greater than upper, your guess is out of range. So these are both examples. The top one with the and means and the bottom one with the two vertical lines means or. And you can string these together. There's no limit that is practical. Whoever was reading your code might take offense if you put too many of them in a row. But so you could do this with nested if statements. So look, I'm saying if guess less than upper, and then inside of that, I'm saying if guess greater than lower, and then I said your entry is within range. That's another way to do this, but I think you'd agree one line with guess greater than lower and guess less than upper. That's a little bit simpler to read and to type and to debug. You don't have as many curly brackets. We also have a not operator, which is the exclamation point. That flips whatever Boolean expression comes next. So check this out. I'm asking the user to enter something. They enter something. And then I'm checking if entry dot equals yes, but not. So that means if they didn't enter yes, then I'm printing out you were supposed to say yes. I mean, I can't explain when you would ever do this, but I'm just giving you an example. So this not, it's not like it doesn't take the opposite of entry. It takes the opposite of that expression, entry dot equals yes, and flips it. So if they entered anything other than yes, then this would be this would trigger because the not. But if they did enter yes, that would turn that into no or false. Not no, but it would turn that expression into false. Here's another example. I made a Boolean variable called is good, set it to true. And then I'm saying, hey, if entry dot index of Liger equals -1, is good is false. If entry dot length is less than 10, is good is false. And then I'm saying, hey, if it's not good, say it's not valid. So this is an example of what we call a flag variable. This is something you can do in programming where you set something to be true or false or 1 or 0 or whatever you want. You have a variable, you put something in it, and then you run a bunch of checks. And you can change what's in that variable in these checks. And then after all the checks are over, then you can evaluate that variable again. So right here, I set this is good variable to be true. And then I had two checks. I said if and this -1 on the index of, that means the word Liger isn't in it. And then if it's too short, either of those things, I'm saying it's not good. And then down here, I'm checking, hey, if it's not good, so not is good. That means if is good is false at this point, then I say your entry is invalid. So a flag variable is one way to avoid having to make a really complicated statement. Like down here at the bottom, I could say if entry dot index of Liger equals -1 or the length is less than 10, then I mean, that's not that bad, but sometimes there's a reason to do a flag variable. Questions so far? One more new concept. It's part of all this. Java uses what's called, it's really a cool thing. It's called short circuit evaluation. Now, normally a short circuit is when you have electronics. Hey, Michael, can you take out your earbuds? When you have electronics and a wire that's not supposed to touches something and kind of wrecks the circuit. In Java, what it means is if you have a compound Boolean expression and and the first or second, let's say there's just two things, and the first thing has already decided the whole thing, it doesn't keep checking. So let me show you for this. This is an or example for short circuiting. If guess is less than lower or guess greater than upper. Okay, if guess is less than lower, it doesn't have to check the second thing. It's already going to return, it's already going to go into this if statement. See, it's checking if this or that. If the first one's true, it doesn't have to check the second one, so it doesn't. That's called short circuit evaluation. It's like a little shortcut. Think about it like a shortcut. Now, if the first one wasn't low, if it wasn't below lower, then it has to check the other one. But in a situation of an or, if the first one is already true, Java stops, doesn't keep going. That's an or example. Now, with an and, it's more of the opposite. If the first one is already not going to work, then it doesn't bother checking the second one because they both have to be true in an and. Both things have to be true or you can't. It won't continue. So if value greater than 0 and the is member variable is true, print welcome, otherwise say invalid. Now, if the value is 0 or less than 0, there's no point in checking if is member is true or not. Like, it's already not going to work because they have to both be true. So I guess you could summarize, if it's an or statement, if the first one's true, you don't have to check the second one. And if it's an and statement and the first one's false, you don't have to check the second one because it's already not going to be true. They have to both be true in an and. So Java, before we do an example, I want to show you a concrete example that is pretty nifty. I thought I just made a copy of this. There we go. A second short circuit and example. So if value not equal 0 and value less than 100, print value, let's see, 75 divided by value. So let's look at this. I'll write the text later. Why would this be handy with short circuit evaluation? Someone tell me in English what this thing is going to do. Let's just say the user is entering some variable value, and we're going to divide 75 by that number. Why would I do this way? Yes?
So it's like if the value isn't 0 and the value is less than 100, then you can divide 75 by the value.
That's what it's doing.
If it wasn't, then there'd be no point.
Well, what happens if you divide by 0 on a computer? It's going to crash. It's just a divide by 0 exception error. So this is a perfect short circuit example. It doesn't even keep going. Like if it's 0, then it's not gonna. We're not gonna divide it or print it or do anything. If it's 0, we don't need to go in there. We're just gonna say invalid. But if it's not 0, then it's like, okay, and let's make sure it's less than 100 or whatever. I mean, the second condition doesn't really matter here, but this is like a nice safety catch. It makes sure you don't divide by 0. Like if you were like, and it doesn't even do the second. It doesn't bother to. It must save just nanoseconds to not do the second half of the check. Like they're just saving a little time on the computer. Like, hey, well, we didn't have to check that because.
But if you're doing like a million checks, then
yeah, if you're doing a million checks, it wouldn't hurt to save a nanosecond. Also, that value less than 100, that could be something that called a method and did like 5 minutes of work. Like it is not a boolean isn't always just like instant. So this would be great to say, hey, if the number is 0, we don't even have to check it. We're just going to say invalid. Okay. I've got the Google form I'll post. That'll be good practice. And then we're going to do the rep. So